Сейчас у нас начнется интервью с создателем языка C++ Бjarne Stroustrupом. Напомню, что задавать вопросы можно в чате. Наши эксперты их зададут уже от вашего имени. А эксперты — это два Сергея. Сергей Платонов, C++ программист, организатор C++ Сибирия, и Сергей Федоров, руководитель разработки бэкэнда Яндекс.Лавки. Ну, далее уже, конечно, продолжим на английском. So today our highly distinguished guest, well known for every C++ developer because he's designer and original implementer of C++, is Bjarne Stroustrup. He's author of C++ Programming Language 4th edition, author of C++ Programming Principle Practice using C++, and many popular and academic publications. Dr. Stroustrup is a technical fellow and managing director in the technology division of Morgan Stanley in New York City, as well as visiting professor at Columbia University. He is a member of U.S. National Academy of Engineering and IEEE ASM and CHM fellow. His research interests include distributed system design, programming techniques, software development tools, and programming language. He actively involved in ICO standardization of C++. He holds a master in mathematics from Aarhus University, where he is an honorary professor, and PhD in computer science from Cambridge University, where he is honorary fellow of Churchill College. Welcome to our broadcast, Bjarne.
Oh, thank you. Thank you. I think I should add to what you just say. I'm an honorary professor at ITMO in St. Petersburg.
Wow.
I was over there when they were doing the programming competitions.
That's great. Yeah, I need to mark it in my books.
Let's make a difference, yeah.
Sure. Yes.
It just seemed appropriate to mention it.
Yeah, that's super cool. Yes, we need to. Next time in St. Petersburg, we'll definitely, connect you with the ITMO again.
Sure.
So, yeah, I think without further introductions, we can start our Q&A. Thank you so much for doing it today. It's an honor to speak with you. So we have several questions from the community, but I'd like to start with just a short, simple ones from like a historic point of view, because it's often asked at the conferences and our user groups. First of all, yeah, you're one of the most mentioned speaker, of course, when we ask people who they want to see at the conferences. They always mention you as the first thought. So they want to have a discussion and some face-to-face experience. So can you just, in simple, like couple of sentences, say how it happened that you actually came up with C++, how it started? I think most of us have read Design and Evolution, but it's interesting if it's possible to put it in a short version.
I can try. It's of course sad that I can't be there in person, and we have about 3-second echo delay, which makes it really hard to have a real conversation. But basically, the way I came up with C++ was I wanted to build a system at Bell Labs that, if I'd actually managed to build it, might have become the first Unix cluster. It was to be a distributed system with some networking and a bunch of computers. And I needed to write a piece of code that had a lot of low-level stuff, very close to the hardware, doing memory managers, process schedulers, network interfaces, things like that. And then I had to get away from the hardware. I had to have high-level things that said that, well, this piece of code there talks to that piece of code there with this particular communication protocol and these particular calls and that kind of stuff. So I needed something that was very low level, very high level. And at the time, there was at least a dozen languages that could do the low level stuff, but C was one of them. And Dennis Ritchie and Brian Kernigan was down the corridor from me at Bell Labs, so it seemed an obvious thing to do. But I found that it was too low level. I needed to have some abstraction mechanisms, and I had experiences with Simula, which I had learned from Christian Nygaard. And so I took the class concepts from Simula and grafted it onto C, making it efficient enough to use for really hardcore systems programming. And so in the process of doing that, I added classes sort of in the second week of the project. I added constructors and destructors at the same time. I needed them for resource management. And then I added what is now function prototypes in C, function argument checking, because I couldn't live without those facilities. And that's how it all started. And so if you go back and see what the real foundation of C++ is, its ability to deal with hardware, ability to abstract efficiently, and the core of that is static type checking and constructors and destructors, what later became known as RAII, resource acquisition is initialization. I was very, very busy in the 80s doing all of this and wasn't all that good at finding nice names for good things. So you have RAII, which is one of the better ideas, and well, it's called RAII. Sorry.
Okay, cool. Thanks. And do you happen to remember at some point that this C++ got out of hand, that you no longer kind of control it, and it's passed to the community?
I don't really ever control it in any strong sense. Once you get users, you get responsibilities, and you have to respond to the users. And for me, that's started about 6 months into the project. I got a user, and I no longer could make arbitrary decisions. In particular, I couldn't make arbitrary decisions that broke things. And then about 10 years later, a couple of people from IBM and Sun and representing HP came into my office and says, Bjarne, you really, really want to standardize C++ under the ISO rules. And I explained why that couldn't be done, and it was too early, and I wasn't ready, and really da-da-da-da. And after about an hour discussion, I agreed because, well, I didn't really have a choice. They pointed out that their corporations couldn't depend on something that depended on a potentially competitive organization like AT&T. And I remember they said, of course we'll trust you, but you might get run over by a bus. And so we started standardization, and by and large, standardization is very difficult, very frustrating. Lots of people have to agree on lots of things. That's hard. From different backgrounds, they have different everyday needs. And I think over the years, we haven't done that badly. Currently, we have a problem that's really much bigger than it used to be. Used to be that 60 people turned up at the meetings, so we could all sort of know each other and trust each other. Now it's 230, 240. We can't all know each other, and that's a much different world and much harder. And then, of course, this year we have to do it all through video because we can't meet face to face. Having the C++ committee meet for a week face to face in a small room would not be good for C++. We would lose quite a few.
Yeah,
So,
that sounds dangerous.
Could you tell, please, about what role in the committee do you play currently?
Yeah, traditionally I was head of the evolution group, and that I retired about 5 years ago, so that Ville Voutilainen took over, and now it's Sebastian. So I always had an unofficial role in trying to look at the integrity of the whole language and have some idea of where we were going in general, beyond the individual features. Very few people do that. Most people look at an individual feature and think it's good or bad. They don't see about feature interactions and such. The focus is on the individual. Somebody, and definitely me, tend to look at the overall language, the general architecture, the fundamentals. And as part of that, I'm part of the direction group that does that. It's a small group of people with a long history with C++ that's trying to maintain a direction. You may have seen me talking about the Vasa, which was a Swedish battleship from the 1620s. It was built at Royal Command to be the most beautiful and the most powerful battleship in the Baltic area. And that was fine. It was going to be named after the royal family, the Vasa. And they got a little bit along the way building it when they noticed that a potential enemy was building bigger battleships with 2 gun decks instead of the 1 gun deck battleships that they had before. And that would have been embarrassing, because if a 1 gun deck battleship stands next to a 2 gun deck battleships, almost certainly the 1 gun deck one will be at the bottom of the sea very quickly with a lot of holes in it. And so the king says, okay, we want 2 gun decks. This is going to be the biggest and the best ship. And by the way, we are going to use it for diplomacy. It has to be very impressive. So we need bigger and fancier and nicely gilded statues all over the place. And the ship designer had some problems with this. Rumors has it that he committed suicide later over the result. But basically, we need more time. We need to rework the foundation a bit. The king says no. I mean, it's like a high-level manager that can't see all the implementation detail problems. No, you built the ship, it sails on the day. They got a bit further on, they built it. And of course, once you build it, you test it. And the way you test a battleship, you take the crew and put them on the one side of the ship, you run to the other side of the ship and back and back. And if you can do it 14 times, it will not keel over in the North Sea and thereabouts. They did it about 7 times, I hear, and it was so dangerous that they stopped. So they skimped on testing. Not a good idea. So anyway, on the day, flags flying, trumpets blowing, the statues being beautiful, the cannons blowing, they go through the harbor in Stockholm, they get halfway across, there's a burst of wind, keels over, and it sinks. And 350 years later, they fished it up and put it in a very beautiful museum in Stockholm. If you ever get to Stockholm, you must go and see the Vasa. It is beautiful. It is impressive. The Standards Committee had a meeting in Stockholm some years ago, and we all went to see the Vasa. And for many years, the slogan was, "Remember the Vasa." Get your foundations right. Don't skimp on testing. Don't put too many statues on, etc. This has been forgotten a little bit, and I'm trying to remind people again. Maybe we should have another meeting in Stockholm. If they had just made the ship about 1 meter and a half wider, this would never have happened. It really would have been what it was supposed to be, but they didn't rework the foundations. They didn't think hard enough about the fundamentals. And on the other hand, they were right. If they had built it without changes and just built a good old-fashioned battleship that they knew how to do, it wouldn't have worked. It wouldn't have been impressive enough for diplomacy. It wouldn't have stood up to a battle. So they have to do something. And so I tell the story to remind people that we actually need to improve things, but we have to be very, very careful how we do it. And you can't just throw random things at a foundation and hope it works. You have to think hard.
So speaking about shiny new guns, are there any features in new standards of C++ that annoy you most?
Not really. I think C++ 20 is going to be great. We finally got concepts. I wanted them back in 86, 88 when I first built templates, and I didn't know how to do it. And we tried again for C++ 11, and we couldn't do it right. I'd hoped to get them in 17 because now we know how to do them, but anyway, we're getting them in 20. We'll finally get properly typed generic programming. And that's going to allow us to express things much clearer, much simpler, and run as fast as ever. That and constexpa simplifies generic programming and compile time programming immensely. The other feature I'm very happy with is coroutines. Coroutines was the bread and butter of C++ for the first 10 years. I was writing simulations and what today would be called multi-threaded programs using coroutines. And they were smaller and faster than anything else at the time, and they're smaller and faster than threading. So that's good. We finally got it back. We lost them because the Sun didn't want to implement them on the Spark architecture because the obvious implementation manipulates stack frames. Today we have a faster one. And then finally, the feature that might be the biggest in the long run, it has to do with program organization more than how you write individual pieces of code. It's modules. Go back, look at DNE, and you'll see me moaning that I don't have proper hygienic ways of splitting programs into parts. We have to use include files and such. We can do better. We knew how to do better back in the 80s and 90s. But introducing something in a language with a few 100 billion lines of code is really hard. And so we're going to get it. They're called modules. They will improve compile speeds dramatically. I have seen speeds from what it used to be with header files up to 50 times faster. I'm hoping to see from many programs, say a factor of 7. And finally, we have a way of stopping macros from percolating through the whole system. You put a macro in a header file, somebody includes your header file, somebody includes your header file, somebody includes somebody else's header files, and your macro creams some piece of code of mine when I include the ultimate file. And I get it from a header file that I'd never heard of. That doesn't happen with modules. And so we get better hygiene. And that's one of the reasons they can compile faster. And I think those 3 features are the most significant ones, and they will have major effects on the way we write code over the next decade. There's a little bit of standard library support missing. There's not a standard set of modules. The library support for coroutines are not quite right. There are some concepts in the standard library, so we're off to a good start. But I hope that C++23 will provide those facilities. It's really hard to provide proper standard library support for something that isn't implemented yet. So we chose to first get the language facilities into the language so that we could try it at scale. We need million-line programs to use this stuff and to use it right, and then gain some experience. And after 23, it will be much easier to use and probably faster.
Thank you. And what about old features, probably that's not used, like output there was removed? Do you think that there is some features in the language that needs to be removed? And following up, because of this 3 seconds delay, following up questions is there any mechanism in this committee to remove these old features? Because that's bigger, and probably it's harder for people to learn it, to keep the pace of learning new features.
This is a huge question and a very difficult one. I don't think there's any major features of C++ that we could remove without annoying a few 100,000 or million people. That is not going to happen. If we are going to be philosophical, I would say that the major features are right and all the details are wrong. And we can't do much about it. We design language and then we see how it works and we rely on feedback. But once something is deployed at scale, it's really hard to remove. Really hard to remove as in we have tried several times with really obscure features and we have repeatedly failed. The mechanism in the ISO standards called deprecation, the general idea you declare that a feature is going to not be used anymore and we're going to remove it in 3, 5, 10 years. It doesn't work for anything significant. We failed to get trigraphs out for 10 years. We've got them out now, but most people haven't heard of trigraphs. It turned out that every IBM machine depended on trigraphs to boot. Take them out, and IBM stops. That doesn't happen. IBM will just stick with the old thing. Again and again, we find that we can declare that things are gone, shouldn't do it anymore. Implicit int was really hard to remove, even though it was never in C++, because C had it. Everybody is dreaming about getting rid of the things they don't like, which they call old-fashioned and such. But they can never agree on which they are. That is, getting a universal agreement among the 4.5, 5 million C++ programmers, you're not going to get it. Furthermore, if you take it out, the compiler vendors will be forced to maintain it for another 20 years, maybe, or 30, like they did with some of the features from back from the ARM in the late 80s. This just doesn't happen. Even if we agree it should happen, it doesn't happen. It's that bad. So now, what do? My opinion is that we can't change anything significant, throw away anything significant, and throwing away anything insignificant is, well, ridiculous. So how do we get people to move ahead? First of all, we have to teach them to write modern C++. There's still a lot of people that start teaching C and how to get yourself into deep, deep trouble with pointers and malloc, as if we hadn't got vectors and RAII and such kind of stuff. Secondly, we need to support that modern style of programming, which is simpler and generates faster and smaller code in reality. When people write their own string manipulation C style, usually they get both bugs and slow code. Experts can do better, but experts have better things to do. And so what I work on with some friends is something called the C++ Core Guidelines, which is trying to say, if you stick to this set of rules, rather than try to use every feature of the language, your code will be better and you'll get to bed sooner. And that's rules. We don't like rules and we can't remember rules. So you need support for that. And so the rules depend on parts of the standard library, and it depends on about 10 little components from the core guidelines support library, which we're busy getting into the standard so that the GSL can disappear, the guideline support library. So for instance, we got span into C++ Penti. Span is a simple abstraction that is basically a pointer plus a size. So if you want to refer to a contiguous set of elements, you get a span, which knows where the elements are and how many there are. So you can do a range for over them. You can do range checking if you want range checking. And basically, you can't get it wrong. If you do a span over an array, say I have an array, I say span span S initialized with A. It'll look at the array, see what type of elements they are. That'll be span's type. It'll look at the number of elements in the array and grab that size. And now you're off. You have a proper abstraction of a continuous sequence of bytes, or of objects, like you need for communication software and other low-level kind of stuff. Dennis Ritchie tried to get something like that into C, and they told him he couldn't do it. So it's not a new idea, but it helps. It's one of these little things that helps. Not every little change is sort of one of the gilded statues on the vasa. Some of them actually genuinely respond to needs in the community. And so the answer to the big question of yours is, one, we can't throw away the old things, but we can build coding guidelines that tell people not to do it. And we can build static analysis tools that enforce those rules. And in particular, the rules I've been working with together with some people at Microsoft in particular and Facebook checks for memory safety. It makes sure that you don't corrupt memory, you don't access a deleted object, you don't lose a resource, you use RAII, and turning on another static checker, it'll make sure that you don't do buffer overflows. For instance, if you use pointers in general, you will sooner or later get a buffer overflow. If you use pointers in general, you'll sooner or later get a dangling pointer. Using the rules, you won't. Use a span instead of the pointer, for instance. Use RAII, and then turn on the checker. It's deployed in Visual Studio currently, so I'm not talking science fiction. And your memory problems go away. They won't pass the checker. I wish that checker was available outside the Visual Studio as a tool you can use on any program on any platform, but that hasn't happened yet. I have an agreement with people that it will eventually happen, but eventually could take a long time. For now, I have to start up Visual Studio and run my programs through it. But it's always good to use more than one compiler anyway, because that way you protect yourself against compiler bugs.
So, speaking about that, well, a big zoo of tools that swarm around C++. Why do you think that C++ has somewhat of a trouble providing a solid ecosystem?
It's because it doesn't have an owner. It doesn't have a single controlling entity. And so everybody builds their own. We started out with no funding. It was a research project at Bell Labs, one person. I did 98% of everything for the first commercial release. Documentation, tutorial, libraries, the works. And our advertising budget was $5,000 for 3 years. I gave $1,000 back because I couldn't figure out how to use them constructively. So what people don't understand is that C++ never had a budget. So instead what it got was a community, but not one community, but many communities. The problem is not the lack of a GUI, it's the fact that we have 25 of them. The problem is not that we don't have a build system, is that we have about 7 of them. That's an underestimate. But and people can't agree. People have their communities. They want to have it their way. They won't merge with others. Some of the concerns are commercial. Some of them are open source. Some of them are big heads. It's sort of a very democratic chaos, and I do not know how to get out of this. Maybe if I had been better at organization building and community building, we could have done something. Should have done something back in the 80s. But in the 80s and especially early 90s, everybody wanted to build a community around their implementation, about their way of doing things. So you had Sortec, Borland, Microsoft, IBM, what's it called? Well, there was 3 or 4 more. And they all tried to build the best in the world to get more users. And sometimes they deliberately made decisions that were seriously incompatible with their competitors because they didn't want people to move to the competitor. And so we have more tools than anybody else, and that is not really an advantage many times. How on earth do I choose a build system? How on earth do I choose my GUI? It's hard. And if I have trouble, just think about a novice.
Especially
Fair enough.
That we don't have, decent build system that will work on any system. And the best we have.
We actually do. We have at least 3 that meet your definition.
Yeah, I said good.
Yes.
So I think we'll move to our prepared questions that we collect beforehand. The second we have, does C++ language rating matters to you, meaning the popularity and everything? And do you follow any metrics? Because, for example, we will have the dedicated talk about C++ infrastructure and its place in the world later on the conference.
I'm not sure I understood that question. I'll try and answer what I think I understood, and then you can correct me if I went off on a tangent. I tend to focus on the language itself in the standard library. I am not really the best person to ask about the C++ sort of world in general in terms of tools and commercials and open source and all of that. There's just too much of it for one person to know. And I don't actually use any real metrics. It's really hard to count anything. Counting users is hard. Fortunately, some of the people are doing it. The people behind JetBrains are running annual surveys. Various of the big commercial guys buy commercial surveys, which they sometimes show to me. That's how I got those numbers, like 4.5 to 5 million C++ developers. But what's a developer? What's a programmer? Do you count students? Do they have to be full-time? These numbers are not very solid, but I think I'm being conservative. I could claim a higher number, and I'm not going to, because that would start counting people that use C++ only occasionally and such, and that's not good. Similarly, people have, if you ask the Qt guys, they can probably tell you how many people use Qt, because they can at least count the ones that are paying, and they can count the number of downloads, which is not a really good measure anyway. I used to think that if people didn't complain, it was because they weren't using C++, because surely it wasn't perfect. I knew that. And then AT&T in the early days did a survey, because they kept track of the distributions, even though they were free. And they found that 4 out of 5 were actually using them when you did a follow-up, which was completely off my guesstimate, which was that I didn't count anybody who didn't complain. It's hard to count.
So you've mentioned that you started designing C++ because you needed something to hide the complexity of networking. So how does it happen that C++ doesn't have any standard networking library?
Again, the problem is not that we don't have a networking library, it's that we don't have a standard. We have many. We've had many since the mid-80s. Currently, most people use ASIO, which is a technical specification, and finally I think C++ 23 will have that, and then people will start talking about the more extended support that is needed on top of ASIO or beside ASIO, or for things they're not doing. But it's the usual chaos in the C++ world. We don't even have a standard place where people store their libraries. Nobody has done a good job of community building with C++. It is pretty amazing that it has survived against fairly serious competition for about 4 decades. I wrote a paper about how C++ managed in the last 15 years for the History of Programming Languages conference. And that paper just became available 2 weeks ago from the ACM. So if you go either to the ACM SIG plan and search for it there, or you go to my homepage and you can find it there under papers, you'll get my explanation about what was going on in the last 15 years. It's called Thriving in a Crowded and Changing World, because that's what we have, and it describes the last 15 years of C++, 2005, 2020, and it describes how we got our standards, 11, 14, 17, 20, and also a little bit about the community problems. A lot of the questions you have asked have deeper answers in that paper than I've been able to give here. I mean, in an interview, there's a bit of hand waving, right? You can't do really solid documentation of your ideas. But most of what I said here is backed up by peer-reviewed stuff in that particular paper. It is not a short read. It's 168 pages, out of which the last about 30 pages are references. So you need a weekend for that.
Thank you. I've sent to the chat of this talk, I've sent the link to the paper, just in case if
Your voice is being chopped. I'm getting sort of the chopping from the communication system. That makes it very hard to understand.
Sorry.
It's
I will try to speak slower. It's usually better, no?
no, that's not good. The likelihood is that if you speak more and faster, the adaptive algorithms will catch up with you.
Cool, then I'll try to speak faster. So I just said that I've sent the link to a paper to chat of this talk. We have special dedicated chat where
Great.
people ask questions, so they don't need to look it up or something. So, and we have next question. Yeah. So, do you think that Rust language has an influence on C++, or it will have some? And is it possible that C++ will borrow something from Rust? Pun included.
No, I think it's more that Rust is borrowing from C++. They just forget to mention it. C++ has had RAII for about 40 years, and I get occasionally accused of having stolen it without acknowledgments. And it's not a very academic or historically oriented community. Similarly, I have been working with what's known as linear logic and ownership semantics for about 20 years. And it's pretty fundamental in the core guidelines, and has been the way I've been thinking about it at least since the mid-2000s. So I think we're actually ahead, but people didn't know it. And so I have not seen anything in Rust that I really feel desperately having to include into C++. Some of the things you couldn't introduce into the language, and so the core guidelines look more like things in Rust, and has done from before I knew the Rust thing. And furthermore, some of the things to do with, say, borrowing is just too complicated. I experimented with that in the mid-2000s, and the code just got too ugly, too much passing around of stuff. And furthermore, with C++, you have to interact with C, and there's some compatibility constraints on what you can do. That makes it a bit hard. But I look at any language that comes along, not any, there's too many. I try to look at the languages come along with interesting stuff. And if there's something there that's good and will fit into C++ and I like it, I will borrow it. I will acknowledge that I have done it. There's people that says you just steal, and no, you write the acknowledgements. But Rust hasn't made it very tempting. So they have people proposing things like mechanisms for deprecating, and to my mind, it just shows that they haven't actually tried yet, and it's too young. They have not tried to get rid of old stuff. It's not that easy. There are problems to do with scale and time that you only get once you have enough users and have been around for enough time so that enough code is there. There was a survey about which languages people loved the most, and Rust won easily. And out of the people who loved Rust more than any other language, 3% had actually written a Rust program. I was surprised. That's just absurd. I had not expected that.
And do you think what's language you like the most besides C++ outside of this like box? Do you have something exotic like the Agda or something like that? Do you have in mind right now something that you want to borrow for C++ from other languages, or even some ideas?
I tend to waffle about any question to do with language comparisons. So I'm not going to talk much about that. However, we do have some plans for C++ 23, which is basically to finish the support for modules, coroutines, and a little bit more about concepts. If we get that done, we have some things that we're looking at for the future. And the one thing that's obviously coming from other places is functional style pattern matching, which I really like. And I first suggested to be put into C++ 17 back in 15. And we're still working on that. And there's a chance we will get it into C++ 23. There's a group of us working on it. It'll give better type checking and some terser code. The C++ version of it will be able to handle both algebraic types and open hierarchies, so it will become an alternative to dynamic casts also, in addition to the traditional functional stuff. And obviously, those ideas come all the way back from, I think, ML. And the other thing we are looking at that could be very significant, which I don't know if we're going to make for 23, is static reflection. Reflection is very nice, but it's also very slow, give large programs, and is an obvious weakness of the type system, and gives errors. So we have been working for some while on a static reflection thing, which basically is let the code look into what the compiler knows about the rest of the program, and then write code based on that. So I'd be able to say, get me a bunch of readers and writers for JSON for a specific set of types. Things like that, and have that done at compile time, so it generates exactly the runtime support for the exact application I want, as opposed to laying down a complete graph of your whole program in case somebody wanted it. You can find the proposals on the WG21 website. WG21 is the official ISO name for the group, and all proposals, all papers are posted there all the way back to 1990 and up to last week, I think.
Thank you. Well, I'm a big fan of static typing, but there is a question from our audience, and it is, what do you think about virtual concepts or adding any other type erasure mechanism to the language?
I'm not particularly keen on that. I'm the co-author of a paper on virtual concepts from back in the mid-2000s, but I don't actually think it has a role in C++. And I am not a great fan of type erasure. We have virtual functions, which some people like to call a type erasure, and I think that's sufficient. I think part of the reason for me talking like this is that I think that we can't consider the programming community as one community. There are distinct communities with distinct requirements. So really flexible, easy to write code is important to a lot of people, but if I'm programming the brakes on your car, or the flight controls of your plane, or the control system for your power plant, I really want it to be done with engineers with a serious technical education, using tools tuned for them and to support reliability and quite often performance. If I'm programming the signal processing for one of these things, performance matters and reliability. And so my guess is that somewhere around 15 to 20% of the development course, development people are in sort of the harder, high reliability, high performance world where C++ has a place. And we should not try and make C++ to compete with Python for having people who are amateurs as programmers, but they might be experts in other fields. We shouldn't compete with that. If you want Python to run fast and to be reliable, let them call a C++ program. Similarly, if you want to make C++ easy to experiment with, quite often the answer is not to weaken the type system or to require less care when you express things. I want do what I mean, not do what you can do with my code by guessing what I wanted. And I think the vast majority of programmers, 80%, 85%, is not what C++ is designed for. Remember the original idea. It was a distributed system with direct access to hardware and some complexity in the system. And if you think about it, anything like that has to be reliable. That is a very different world from the world that a web app developer lives in. And hey, JavaScript is great for what JavaScript is doing. And I have a policy not to say anything rude about C++ applications, such as the JavaScript engines. There are two worlds, and sometimes they come together. Very often with C++ being the foundation that something else runs on top of.
Thank you. And again, probably about old features and removal and everything like that. But I'll try to ask in a more general way. Is there any plans to improve integrity of the language by the price of the, removing breaking compatibility, backward compatibility? So, for example, can we get rid of the preprocessor to make C++ great?
The general strategy, the only strategy I know that works, is to provide a better alternative and hope that the old stuff goes away. The old stuff never really goes away, but it can go away in my code. It can go away in some sub-world. And it can then, once there's an alternative, you can suggest to your friends and your suppliers that they stay away from those things, or they encapsulate them. Modules can encapsulate all the old stuff. Inside a module, you can have a program written littered with macros and includes. But I don't mind as long as those macros and include files don't escape into my code. So that's an important idea. And yeah, I think that's the only way of moving forward. And for individual features, you can do similar things. I don't like casts, for instance. I very rarely use them. And when I have to use them, like being close to the hardware, writing software, encapsulate it into something that actually is type safe and follows the rules.
Thank you. Can you tell Why was it decided not to make the move semantics destructive in C++?
That's a question that's really hard to answer while waving your hands. But basically, it wasn't quite right, and it appeared to break some things so that it would be really hard to deploy at scale. That idea, if it works, needs more work. And I can't go into details here. For starters, I would need at least a whiteboard.
So probably we'll ask you next time.
I'd have to look at the 2 or 3 versions of that idea that had been proposed. It's too detailed.
Okay, thanks. And we have the question from the chat. People ask that. So the C++ compiler is quite complicated nowadays. Do you have any advice how to study, develop modern compiler, how to understand the theory, get the practical skills? Because more compilers, better.
The compilers are big and complicated, and I think everybody is trying to modernize their compilers without breaking anything, as usual. There's some work going on to modernize the internal representation, both in GCC and in Microsoft. A main driver of that is the modules, which have to be represented and represented well. If you do a good job of that, and so you represent it as an internal representation that's typed and minimal, then your use of modules become much faster. Whereas you represent it as a bag of bytes, you have to recompile that bag of bytes each time you use the modules, and you don't get so many benefits of the modules. Yes, it's encapsulated, but it's still slow. So I think everybody, and definitely I know GCC and Microsoft, are upgrading their internal representations. I know that some of the work at Microsoft is being done by my old friend Gabby Dos Reis. When we were both professors in Texas about 10 years ago, we designed a representation for C++ that was minimal in size and minimal in number of interactions needed, called the IPR. And that's the basis of the module implementation at Microsoft. And I think it is spreading. It's a very nice representation. It's demonstratively smaller and faster than alternatives. But of course, to fit it into existing compilers, you have to add things to do with, say, the debug information and such, which it, in its simple form, doesn't have. But again, go to my homepage, look for a paper called something like a principled and general representation of C++. It was called IPR, my usual creative way with names, internal program representation. Because I don't like the phrase AST, abstract syntax tree, because they're not abstract, it's not syntax, and they're not trees. But that's what people usually call them.
Thank you. Another question from our chat. Well, C++ is notoriously known for undefined behavior, and is there any kind of strategy within the C++ standardization committee to reduce the number of undefined behavior cases?
Not all undefined behavior is bad, which people tend to forget. You could very well require a defined behavior that was the wrong behavior. Like you get undefined behavior with overflow with integers. You can get rid of that by using unsigned, which use modular arithmetic, which means that what looks like an overflow just gets you back to 0. And so you get runtime errors instead of undefined behavior, which can be detected by tools and compilers and really is. Now, there is a group looking into undefined behavior and trying to make sure that basically what is undefined is well defined. That is, we know what is undefined and how it's undefined, and get rid of the things that that doesn't fit that pattern, because there are quite a few things that needn't be undefined, in my opinion. For instance, we got the order of evaluation better defined over the objections of some compiler writers that claimed that undefined order of evaluation was good for you because it gave you faster code. This was not true, but so we're making progress. And by the way, it's again Gabidos Reyes that's in charge of that undefined behavior business. So he's head of the working group on that. So yes, we're looking into it, and we know about this, but you should be aware that people just say, "Oh, undefined behavior, it's all bad." It's not all bad. The alternatives can be worse. I guess that means it's still bad, but the alternatives are worse. Sometimes.
So I will still continue with the removing pattern. Today it's my feature, I guess, asking about things that people want to remove from the standard. And this one is about new feature, actually. And we had during several C++ Russia several talks about failing of initializer list. Do you know about some plans to improving it or like making it work right?
We're trying to improve them a little bit, and I would like to know more about what people think are the failures.
Okay, I will.
You could send it to me if you have it. That would actually be helpful. The initializer lists are not exactly as Gabidos Reyes and I proposed them. They got improved on the way, and in my opinion, the improvements weren't improvements. And we have gradually actually made them less error-prone, more powerful, more useful, and I think that will carry on. And if somebody has, especially examples where it doesn't work too well, I'll be very interested to know it, because it's hard to guess what really bothers people, and you have to talk to people. This is, by the way, one thing I really dislike about video talks. I can't chat with you before or after the talk and see what you really think are the problems, learn from it, try out ideas. Would this help you? Would that help you? Face-to-face is important for that, and I miss it severely with all this video stuff.
Yeah, of course. We miss offline meetings as well, as you can imagine. And we just forced to do it that way. So thank you again for agreeing.
And by the way, you have a C++ standards committee in Russia. You can join that. You can join the meetings, and you can use that as a channel to get suggestions through. But note that I like problems much better than solutions, because once I know the problem, I can work on the solution, whereas people's solution is often the first one they thought about for their particular problem. And different people have different problems, and to get things into a language that really works, we need to pool the problems from a variety of people and then provide a solution that works across the spectrum.
Yeah, and just to follow up, again, I've sent link to our working group, Russian National Working Group. It's called this stdcpp.ru, and it's actually a public forum where you can online discuss make your idea public, and it will be voted by the community, and you can discuss it later on. And we have three members of the ISOs of Working Group 21 that will represent your idea. If it will be really popular, they will help you to make it to paper, like represent it as a paper. And it's actually happened, it's proved that it's working. Several ideas are currently discussed at the committee, like wide int, for example, it was proposed via the website. And by the way, it was proposed by the student, not even like experienced C++ developer, but by a student, and he's now co-author of the paper that's actually discussed now. So I actively ask people to participate in the working, and usually all these meetings of this working group, of the national working group, are public, and we make it as a kind of a meetup, local meetup usually held in Moscow. So please participate.
This is great, but I will encourage you to remind people that most languages ever designed have died. We've had at least 10,000 languages that have been designed, usually fulfilling all of the requirements of their designers and all the fashions there were, and 10,000 of those roughly has died. So successful language design is not really a popularity contest. You have to think about the larger community. Is what your problem is the same problem as they've got in California and Wuhan and Bangalore and places, and is what's in your industry the same as problems in some other industry? And then the fact that a lot of people use something like C and C++ just because they are old. Code that they wrote 10 years ago still runs. This gives people the encouragement that code they write today will run in 10 years' time. And a lot of major users have that specific concern. This is why I emphasize compatibility, and why I may regret that I can't make improvements and break compatibility, and why I'm reluctant to do so, because we have hundreds of thousands of millions of people who says, I want all of this new stuff, and I don't want all of this old rot, and don't break my code.
Fair enough. A very popular question among our audience is, what tool chain do you use on a day-to-day basis? Do you write programs?
Yeah, I write programs every day. I use two tool chains. I'm sitting here, and there's a screen there, and there's a screen there. That screen is a Linux box, and I use some clusters of Linuxes for something. And that one is a Windows box, and that's a GCC and build systems and all of that. And this one over here is Windows, Visual Studio, and small stuff. I mean small stuff because this is a quad-core i7. These machines are big on the other side. So I used to also use a Mac, but I couldn't keep up with 3 different systems. So now I'm only using 2. But I consider it distinctly dangerous for a designer to use only one tool chain. You end up thinking that tool chain is right and everything there is, and everybody's using that tool chain, and if they aren't, they should. That's a very dangerous attitude. So I use 2.
So if you've got a cluster of Linux boxes, why don't you use some sort of continuous integration system to run different tool chains?
Maybe I do. That's the corporate one. By the way, the Windows box can talk to the rest of the world without security problems. I work for a bank. You know, people want to break into the bank because that's where the money is. So the security issues can be a bit bothersome about what to do there. Whereas on that machine, it's my machine. If people break into my machine, I will be very sad, but the world wouldn't be affected by it. It will just be me. And that machine, I can run any system I can download. And as a matter of fact, it does run the Microsoft compiler, the Clang compiler, and the GCC compiler, all three of them. I don't go further. I should have an Intel one and a bit more. But again, setting up tool chains and maintaining tool chains is almost a full-time job. So I can only do so much while still doing my day job and my teaching and my C++ stuff.
Oh, thank you, but I think the question was more about tools you use, not the tool chain in the meaning of which compiler do you use, but for example, address sanitizer, static analyzer, something like that. So as a software developer in your everyday life, do you use debugger?
Do what? Sorry.
Do you debug your software? Do you use like GDB or something like that, or do you use Godbolt to analyze output of your? So
I use Godbolt Compiler Explorer a lot. I use what's the other one? The OneBox a lot. I do use the static analyzer, mostly the one in Microsoft, because it does the core guidelines. Not trying tidy very much because it's pretty weak in the areas I'm interested in. I don't use debuggers all that much. For looking up things, it's CPP reference. And there's just so much.
Okay, thank you. And there was a question, if it's not like NDA or if it's not a secret, can you share with us what you was working on last 2 or 3 years? Like, what's the project?
I've been, what you see me working on, you can see in my proposals from the standard committee, and I've been deeply involved in getting C++ 20 ready. A lot of this has been details over the last years, but you know, modules, coroutines, concepts. I worked on the contract stuff that didn't work out. And then on a variety of smaller issues, and then I wrote papers about direction. I wrote the paper about the history in the last 15 years. I've been working and worked continuously on the core guidelines. We have meetings. It's Microsoft, Facebook, Red Hat, lots of people. I can't talk too much about what I'm doing inside the bank, but it's fairly basic sort of networking, distributed system stuff like I've been doing for the last 40 years. And they have very draconian constraints on reliability and performance, which makes this kind of stuff interesting. When I was an academic, I could count microseconds. Now I have to count nanoseconds. But it's still the same distributed system stuff, and it's the same problems about old code getting too old and having to be modernized. It's the same as everybody else. And then once a year, I give a university course.
Ага. Thank you. I would to say really thank you for this great interview, Björn, and also I want to thank Sergey and Sergey, our experts, for interesting questions. I believe that there is a lot of questions to be discussed. So should we proceed the QA session in the discussion zone?
Okay.